Let's do problem 43 on page 221 in chapter 8. And I'll read the problem from the book. Right here, it says, a centrifuge rotor has a moment of inertia of 3.75 times 10 to the negative 2 kilogram meter squared. How much energy is required to bring it from rest to 8,250 RPM? So here is the problem. Oh, and here it is. And so we want to know how much work does it take to spin this thing up. So this is just some object. It's a centrifuge, some part of a centrifuge. We're going to spin it really fast. And we want to know how much energy is it going to take. How much work do you have to do to get it to that speed? So, well, the work done will equal the change in kinetic energy, which is K final minus K initial. And the initial kinetic energy, it starts from rest. So this is going to be 0. So the work done is going to be our final kinetic energy, which is 1/2 I, the final angular velocity squared. And I know what that is. I know what I is. And all I need is omega, but it needs to be in radians per second for this to work. So 8,250 revolutions per minute. We got to change this. 1 revolution is 2 pi radians. And 1 minute is 60 seconds. So this, by doing unit conversions like this, you can tell whether to multiply or divide or something. Some of you got these a little bit mixed up. So get on it when it comes to unit conversions. The most useful thing you'll learn in here and in chemistry is how to do unit conversions. Anyway, so this is omega. So omega is equal to, well, let's see, 8,250. Oh, wait, let's clear my calculator. Times 2 times pi equals, divided by 60 equals, and I get 863.9 radians per second. So now I can figure out how much work is done. Notice I make a capital W, not an omega. 1/2. Now what is I? 3.75 times 10 to the negative 2 kilogram meter squared. And then this is 863.9 radians per second squared. So now this number is already in my calculator, so I'm just going to square it. And then multiply it by 3.75 times 10 to the negative 2. And then divide it by 2. And I get 1.4 times 10 to the 4. Now what units do I get? Yeah, it should be, it's just joules. Now, if you want to say, some of you left it kilogram meter squared, radians squared per second squared. Okay, that's okay, that's fine, I suppose. But this is a joule. Remember, a joule is a newton. A newton is a kilogram meter per second squared. A newton times a meter, so that you get the meter squared. And so this is a joule. And then you do need the radians squared in there to make the thing work out. But anyway, this is our answer. One thing, a couple of folks, I think they knew what the answer was supposed to be, but the work got messed up. If you have the correct answer, but your work doesn't lead to that answer, you're going to get, it's pretty severe. So make sure that you enter in the work, even if you know what the answer is, because maybe you whiteboarded it and you remember it or something. But make sure that your work leads to that answer. If it doesn't, you'll at least get most of the credit. But if it doesn't, I'm going to have a problem with it. All right. So anyway, if you're doing it with a as a homework quiz. Anyway, any questions on this problem? All right. That is all.